Introduction to Torque, written by Daniel J. Inman from the University of Michigan. Have you ever wondered what makes a wrench turn a bolt, or how a car engine generates power to rotate the wheels? The answer lies in a concept called torque. Torque is a fundamental principle in physics and engineering, playing a crucial role in various aspects of our daily lives. This essay aims to provide a comprehensive guide to torque measurement, unraveling its mysteries and highlighting its significance in different fields. Understanding torque, a measure of rotational force. Torque, often described as a rotational force, is a measure of the force that causes an object to rotate around an axis or pivot point. Imagine trying to loosen a tight bolt. When you apply force to the wrench handle, you create a twisting force that turns the bolt. This twisting force is torque. The magnitude of torque depends on two factors: the force applied and the distance from the axis of rotation to the point where the force is applied, also known as the lever arm. The greater the force or the longer the lever arm, the greater the torque produced. For instance, it's easier to loosen a tight bolt with a longer wrench because it provides a larger lever arm, increasing the torque applied. Instruments for measuring torque. Measuring torque accurately is essential in many applications, from ensuring the proper tightening of bolts in machinery to optimizing the performance of electric motors. Various instruments are available for measuring torque, each with its own working principle and application. Some of the most common torque measurement instruments include torque wrenches. These handheld devices are widely used in mechanical engineering for tightening bolts and nuts to a specific torque value. They typically feature a mechanism that clicks or provides a visual indication when the desired torque is reached. Torque sensors, also known as rotary transducers. These sensors convert torque into an electrical signal proportional to the applied torque. They are commonly used in industrial settings for real-time monitoring and control of torque in rotating machinery. Load cells. While primarily designed for measuring force, load cells can also be used for torque measurement in conjunction with a torque arm. The torque arm converts the rotational force into a linear force, which is then measured by the load cell. And finally, dynamometers. These devices measure torque and rotational speed simultaneously, providing valuable information about the power output of engines, motors, and other rotating equipment. Static and dynamic torque measurement. Torque measurement methods can be broadly classified into two categories: static and dynamic. Understanding the difference between these methods is crucial for selecting the appropriate technique for a particular application. Static torque measurement refers to the measurement of torque in a non-rotating or stationary condition. This method is suitable for applications where the torque remains constant, such as tightening a bolt to a specific torque value. Torque wrenches and some types of torque sensors are commonly used for static torque measurement. Dynamic torque measurement, on the other hand, involves measuring torque while the shaft or object is rotating. This method is essential for applications where the torque fluctuates or varies over time, such as in engines, turbines, and electric motors. Dynamometers and specialized dynamic torque sensors are used for this purpose. Performing accurate torque measurements requires a well-defined experimental setup and careful consideration of various factors. The specific apparatus needed may vary depending on the application and the chosen measurement technique. However, a typical torque measurement setup generally includes the following components. First, the torque source. This could be an electric motor, an engine, or any other device that generates rotational force. Next, the torque sensor. As discussed earlier, various types of torque sensors are available, each with its own advantages and limitations. The choice of sensor depends on the magnitude of torque to be measured, the required accuracy, and the nature of the application, whether it's static or dynamic. Then, the data acquisition system. This system is responsible for collecting and recording the electrical signals from the torque sensor. It may consist of a digital multimeter, a data logger, or a computer with appropriate software. Also, the couplings. Couplings are used to connect the torque source, the torque sensor, and any other components in the system. It's crucial to choose couplings that can transmit the torque accurately without introducing significant errors. Finally, the torque arm, if using a load cell. If a load cell is used for torque measurement, a torque arm is required to convert the rotational force into a linear force that can be measured by the load cell. Let's illustrate the process of torque measurement with a step-by-step example using a load cell and a torque arm. This method is commonly used in laboratory settings and industrial applications for its simplicity and versatility. First, calibrate the load cell. Before conducting any measurements, it's essential to calibrate the load cell to ensure its accuracy. This typically involves applying known weights to the load cell and recording the corresponding output signals. Second, assemble the setup. Connect the torque source, the torque arm, and the load cell. Ensure that all connections are secure and that the torque arm is perpendicular to the direction of the force applied by the load cell. Next, apply torque. Start the torque source and gradually increase the torque to the desired level. Then, record data. Monitor the output signal from the load cell using the data acquisition system. Record the load cell readings at various torque levels. Finally, calculate torque. To determine the torque, multiply the load cell reading, which is the force, by the length of the torque arm. For example, if the load cell reading is 100 newtons and the torque arm is 0.5 meters long, the torque would be 50 newton meters. Torque, M, equals sine force, N, x distance, M. So, torque equals sine 100 nx 0.5 m equals sine 50 nanometers. Analyzing torque data experiment and calculation. After conducting the torque measurement experiment, it's essential to analyze the collected data to draw meaningful conclusions. This typically involves creating tables and graphs to visualize the relationship between torque and other variables, such as rotational speed or angular displacement. For instance, if you're measuring the torque output of an electric motor at different speeds, you can create a table like the one below. Speed in RPM, load cell reading in newtons and torque in newton meters. 100 RPM, 20 newtons, 10 newton meters. 200 RPM, 40 newtons, 20 newton meters. 300 RPM, 60 newtons, 30 newton meters. 400 RPM, 80 newtons, 40 newton meters. By plotting this data on a graph with speed on the x-axis and torque on the y-axis, you can visualize the torque speed characteristic of the motor. Analyzing this data allows you to understand how the motor's torque output varies with speed, which is crucial for optimizing its performance in different applications. Common errors in torque measurement and their solutions. While torque measurement techniques are generally reliable, several factors can contribute to errors in measurement. Identifying and addressing these potential errors is crucial for ensuring the accuracy and reliability of your results. Some common errors in torque measurement include misalignment. If the torque sensor, the torque arm, or the couplings are not properly aligned, it can introduce significant errors in measurement. Ensure that all components are aligned coaxially to minimize misalignment errors. Friction. Friction in bearings, couplings, or other rotating components can affect the accuracy of torque measurement. Use low-friction bearings and couplings and lubricate them properly to reduce frictional losses. Temperature effects. Temperature variations can affect the sensitivity and accuracy of some torque sensors. Use temperature compensation techniques or choose sensors with low temperature sensitivity to mitigate these effects. Electrical noise. Electrical noise from nearby equipment or power lines can interfere with the signals from the torque sensor, leading to inaccurate readings. Use shielded cables, grounding techniques, and signal filtering to minimize electrical noise. Applications of torque measurement across industries. Accurate torque measurement is essential in a wide range of industries and applications, including automotive. Torque measurement plays a crucial role in engine testing, transmission design, and vehicle dynamics analysis. Aerospace. Torque sensors are used in aircraft engines, control surfaces, and landing gear systems to ensure safety and performance. Manufacturing torque control is essential in various manufacturing processes such as tightening bolts in assembly lines, controlling the tension of materials, and monitoring the performance of robots. Energy torque measurement is critical in power generation, transmission, and distribution systems. It is used to monitor the performance of turbines, generators, and other rotating equipment. Medical devices. Torque sensors are used in medical devices such as surgical instruments, prosthetics, and rehabilitation equipment. Conclusion: the significance of accurate torque measurement. Torque measurement is an essential aspect of various engineering disciplines and industrial processes. From designing efficient engines to ensuring the structural integrity of buildings and bridges, accurate torque measurement plays a vital role in our technological advancements and daily lives. Understanding the principles of torque, the various measurement techniques, and the potential sources of error is crucial for engineers, technicians, and anyone involved in applications where torque plays a significant role. As technology continues to evolve, we can expect even more sophisticated and precise torque measurement devices and techniques to emerge, further expanding the possibilities in various fields.